Hi guys, welcome to another episode of MrLopezClasses.com. This is an special episode. We are going to analyze the sensors, the codes, the problems related with each sensor, the signals, the solutions, and the symptoms. Yes, my friends, we are going to analyze all of those sensors. This video is for gas and diesel. It's exactly the same because the codes, the OBD2 codes, are universals and they apply for any type of engines. Doesn't matter if it's diesel or gasoline. The troubleshooting for each sensor is pretty similar. If you have the manual of any type of car, the procedure to check each sensor is pretty similar, and the range of values in ohms or volts or millivolts is practically the same. For that reason, you need to understand the procedure to check each sensor and where is located the sensor and how can I go to administrate the troubleshooting in each sensor. Let me explain something about the sensors. The sensors are points of reference of the computer. The computer needs the sensors in order to take decisions. For the computer, it's impossible to take decisions about increase the RPMs, decrease the RPMs, increase the amount of fuel, decrease the amount of fuel, if the sensors never send the appropriate signal. Yes, the sensor is a vital component in the harness. At the end of the day, the harness is composed by the computer, the wires, the cable, the harness, the terminals, and the sensors. Yeah, this is a system. It's a complete system that administrates the engine. All of the engines are pretty similar, and all the sensors work in the same way. There are sensors that work in one direction. There are sensors that work in both directions. What is the meaning of that? There are sensors that send signals and receive signals. There are sensors only dedicated to send signal to the gauge, not the computer. For that reason, let me explain something in relation with the sensors. There are sensors with one terminal. Sensors with only one terminal. For example, in all engines, the coolant temperature sensors or the oil pressure sensor. Those sensors with only one terminal, that terminal is connected to the gauge, for example the oil pressure gauge, or for example the coolant temperature gauge. And what about the ground? The ground is because those sensors are bolted on the thermostat housing or on the oil bracket. This is the ground. The ground is with the block of the engine. Those are the sensors with only one terminal. Normally those sensors are dedicated for gauge, to the gauge, oil pressure gauge or temperature gauge. Yeah. There are sensors with two terminals. Those sensors work in some cases with gauge. One terminal is ground and the other terminal is the signal. Normally, doesn't matter which terminal you select. You can select one for ground and the other one for signal. Those sensors can be used for the gauge or for the computer. Those sensors receive signal from the computer. The sensors with two terminals. There are sensors with three terminals. They have two terminals with constant power, positive and negative, and other terminal, normally the middle one, for the signal. And this is the reference signal from the computer. And there are sensors with four terminals. Those sensors, they have two terminals with constant power, normally from the computer or from the ignition switch, and the other two terminals, the other two pins, are one to send signal to the computer and the other one to receive signal from the computer, which is depend of the sensor and depend of the manufacturer and depend of the engine. For that reason, my friends, the most important part is the wiring diagram. If you have the wiring diagram, you can follow, like this diagram that you have on the screen right now, you can follow the pins on the socket of the computer, and you can identify which pin is dedicated per each sensor. This is a great example. In all the service manual, at the end of the service manual, you found a wiring diagram similar to this one per each engine, and you can identify which is the pin in the computer dedicated for that sensor, and you can follow that cable, and you can identify continuity in that cable, and you can verify if the output coming out from the computer is okay, or if the return from the sensor is good. For that reason, my friends, I recommend try to prepare tools to check the sensors. Let me explain something. Normally, the majority of the sensors can be checked in two ways. The first way is when the engine is off. When the engine is off, the majority of the sensors can be checked with resistance, with ohms. You remove the plug of the sensor and, for example, throttle position sensor. We remove the plug from the throttle body and we connect my multimeter in ohms in both terminals of the sensor. What happens if the sensor is three terminals? You identify which is ground and which is the signal. Okay, in between signal and ground, you connect your multimeter in ohms, and you move the flap of the throttle body, and you verify if the resistance goes up and down, increase and decrease. I don't have the manual, I don't know how much should be. Doesn't matter. The only that you need is verify if the resistance increase in wide open throttle, decrease. Okay, it's working. If you have the manual, you can verify how much is the value in ohms in wide open throttle and the value in ohms at idle. Normally, the majority of the sensors can be checked when the engine is off with ohms, resistance, ohms. And the majority of the sensors can be checked when the engine is running with voltage. In the same example, the throttle position sensor, I connect the plug, I start the engine, and I introduce needles in each cable to check the voltage. Or I can prepare tools like the tool that we are going to explain right now with Professor Rodriguez in order to interrupt, remove the cable, remove the terminal from the sensor, and install the adapter. How can you fabricate those adapters? It's simple. If you have an old harness, you cut it, the terminals where the terminals enter into the sensor. You cut it that one, and with this piece of harness with terminal, you fabricate that tool. The tool that Mr. Rodriguez explained right now. Danny, in other type of engines, especially in diesels, I prepare a lot of tools when I check the sensors. And normally I use all harness, I cut it. You have the same technique here?
Absolutely. Old harnesses are like gold.
It's gold,
It's like gold. You can take the harness and make test tools out of the harness.
Correct, because you cut it, the cable per each sensor, and you have right now the wires free to check voltage, to check resistance, whatever you want.
Not only that, you can have a system that you make that hooks everything up, and the wires are spliced out, so the system's actually connected.
Correct.
And you can actually physically see how it's running, and you can actually test it while it's running.
And you can test the voltage
without probing any wires or anything.
Yeah, that's good. And this is only possible if you have an all harness and you collect those harnesses.
That's something they don't give you. That's something with experience over time you'll end up getting on your own.
Normally when I visit marinas, my first step is check in the green garbage can at the entrance. I found that pumps, cables, harness, a lot of gold for me.
Absolutely.
Yeah, this is a secret, my friends. Prepare tools to check the sensors, and it's as simple. It's with harness, and you cut it and you prepare those wires.
I'll show you some ones that I made.
This engine that you removed 5 minutes ago. This engine is a great opportunity to explain the tool that you prepare to check sensors and terminals.
So how I made this harness, and like I said, this is each individual makes their own harness. I made mine like this so I can put my meters in there to test for power, continuity, grounds through there. And so what I do is this system here is you break the system apart.
Okay, this is for the injector specifically.
And then you can do this is put this in line. So you never interrupt the system.
Correct. The system continue over there and you have access to connect your multimeter over there. That's perfect. That's perfect because the system is running, the engine is running, and you can verify the voltage. You can verify in this particular engine if the injector is receiving 55 volts from the computer.
Correct.
55 volts intermittent. No?
Yes, it's controlled by the computer again.
Exactly the same. It's the same you can do with the rest of the sensors.
Oh yeah, I have more. I have them for almost every different thing.
But let me explain, guys. This is part of the harness. This is part of the harness. You cut the harness. You cut the harness and you install those 3 terminals.
Yep. I cut the harness and just splice them in so I can test it.
Incredible. This is a great opportunity when you visit a marina, and if you found that harness, if you have found that harness on the garbage, collect those harness because this is gold for you. This is money for you. If you have this tool, you can solve millions of problems. If you are a good technician, you need prepare those terminals for the different type of engine that you are working, no?
Yeah, we have them for different motors. I mean,
For
this is just
motors.
this particular motor.
Correct.
Remember, being a technician, time is money, okay? And having the right tool gets the job right correctly and done quickly. So by making these harnesses, not like you can buy these harnesses. This is harness that you have to make yourself. But there's so much value to them because you can do so much testing so much quicker than you would if you were just going by the book.
Okay, with that tools, I recommend, I will be dedicated in the next coming 10 years to work with the Mercruiser, to work with Yamaha, to work with Caterpillar. Okay, I am going to prepare those tools, those terminals, those connectors in order to check the different type of sensors. Yes, it's very important. Those tools is simple. All the time, if you found that engines abandoned, remove the harness. This harness is gold for use. You need cut those terminals in order to fabricate the tools to check the sensor when the engine is running. Right now, with that tool that Mr. Rodriguez made, with that tool, you can check each sensor when the engine is running. Okay. In that case, if the engine is running, with that tool, you can check the voltage and you can verify if the voltage increase or decrease. We are going to check right now in each particular sensor how much should be the voltage when the engine is at wide open throttle, how much should be the voltage when the engine is in idle, or how much should be the temperature. Exactly the same. We are going to check 2 parameters with the multimeter. Ohms, normally, when the engine is off and you remove the plug and you check ohms in each sensor. Or voltage, when the engine is running, you install the adapter and you check how much is the voltage in wide open throttle, in idle, in different options. Okay? And the procedure is exactly the same. All the sensors have a similar procedure in order to check how is the sensor working. Alright. other important thing is this. Normally, when you have a code on the dashboard in your boat, in your car, you need verify where is the problem, and you need fix the problem, and you need analyze the engine. When you fix the problem, you can clean the code. This is a common mistake of the technicians. The technicians say, I need that somebody borrow the computer because I need clean a code in that engine. I have a question. You solved the problem? Oh, I replaced the sensor. They said oxygen sensor, I replaced the sensor. But the code stay on again. Yes, because probably the problem is not on the sensor. Probably the problem is a mechanical problem on the engine. How many times you replace the sensor? Oh, I replaced the sensor 3 times and the code continue. The problem is not the sensor. The computer read oxygen sensor because this is the element that read the inconvenience. But the inconvenience, the problem is in other place. You need to analyze the mixture, you need to analyze the temperature, you need to analyze other parameters. Finally, at the end of the circuit, that element read different voltage or different ohms, and the computer immediately start the alarm. Before you try to clean a code, you need to solve the problem. If the problem is not solved, the code start again. Alright? Be careful with that. This is the most important part. For that reason, my friends, I need that you be analytic. I need that you close your eyes, analyze the engine, and try to check all the possibilities per each code. My friends, if you have clear the engine, the harness, if you have the oil sample report, if you have the coolant sample report, you can solve any problem in the engine. You don't need visit the boat probably. If you have the oil sample report and you have this table, the table related with the oil sample, you can analyze each metal, each element dispersed in the oil, and you can identify where is the problem. Also, if you have the coolant sample report and you have this table, you can analyze each element, each contaminant, each additive, and you can identify where is the problem. Yes, my friend, you can buy those tables properly laminated in my web page, in my Facebook. This is a great information. And also, if you have the table related with the codes, that table, you can identify where is the symptom, the consequence, the solutions, what type of codes are related with each sensor. This is a perfect table. Those 3 tables are available in my web page, in my Facebook. Alright. I want that you be a doctor. Exactly the same when you visit the doctor. What is the first step when you visit the doctor? Blood test. And what happened the next day? The doctor had the report, and the doctor said you have high level of iron, low potassium, low zinc. Oh, you need reduce this, increase this, because the doctor have the information of your body. This is exactly the same with the oil sample report, the coolant sample report, and the codes. Okay, my friends. Now we are ready to start to analyze the codes and the sensors and what happened with each sensors. My friends, don't forget, the sensors work exactly the same in different engines. Doesn't matter if it's diesel, if it's gas, if it's 2-stroke, if it's 4-stroke. The sensors have the same function. And those are the most common sensors that you found it in the different type of engines. And we are going to analyze one per one. We are going to analyze the first one, CTS, coolant temperature sensor. The TPS, throttle position sensor. The O2, the oxygen sensor. The CMP, camshaft position sensor. Crankshaft position sensor. Mass airflow, MAF. Manifold absolute pressure on the intake manifold. Intake air temperature sensor. NOx sensor. Exhaust gas recirculation valve. Fuel pressure regulator. And purge control valve. The emission side of the engines. Those are the most common sensors, and we are going to analyze those sensors. We are going to analyze the codes related with each sensor, and we are going to check what is the cause for that problem, where is the solution, and the signals. We are going to start with the first one, with the coolant temperature sensor, and we are going to verify the symptoms. What are the symptoms when that sensor have a check engine light working? Okay, symptoms. Coolant temperature sensor. What is the first symptom? Of course, overheating. Overheating. Detonations. Ba 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 ba. Misfiring. Loss of power, of course. Loss of power. Knocking. Misfiring. Backfiring or stalling. Those are the most common symptoms for coolant temperature sensor codes. Coolant temperature sensor. Let me refresh quickly about the coolant temperature sensor. Where is located? The coolant temperature sensor is located at the thermostat housing. Yes, at the thermostat housing. Remember, in the thermostat housing, normally you have one coolant temperature sensor and the other one is the coolant temperature switch. One is the sensor and the other one is the switch. The switch is used when the temperature passes the limit. The switch interrupt the current on the run relay on the harness. That's the switch. And the sensor works for two functions. Send the signal to the gauge, temperature gauge, and send and receive information to the computer. The sensor dedicated to computer and gauge, and the switch to interrupt the current on the harness. Very important. Where are located both of them? In the thermostat housing. Yes, in that element where the thermostat is located. In any type of engine, gas or diesel, inboard or outboard, on the thermostat housing. Yes, in some outboards, the coolant temperature sensor is on the head pretty close to the thermostat. Correct? Alright. That's the coolant temperature sensor, and those are the symptoms. Overheating, detonation, loss of power, knocking, misfiring, stalling. Those are the most common symptoms. Okay, we are going to analyze the codes. What are the codes normally related with coolant temperature sensor? Okay, PO 115, 116, 117, 118, 128, and P2 185. And those are DTC codes, marine codes, in some marine scanners. But those are the most common codes related with coolant temperature sensor. Once again, my friends. Oh, I am going to replace the coolant temperature sensor. No. 98% of the time, the problem is not on the sensor, in that specific case. There are millions of possibilities. We are going to analyze only that sensor, the coolant temperature sensor. One possibility for that alarm, coolant temperature sensor, I have the code P0116. P0116, coolant temperature sensor. There are millions of possibilities. Probably on the raw waters. Remember, if you have temperature problems, what is the first step? You need analyze the situation and isolate the problem. My problem is in the raw water side, or my problem is in the coolant side. If my problem is in the raw water side, I need analyze from the a.c.r valve, after that the raw water pump, after that the strainer, and after that the elbow of the exhaust. You need analyze all of that system and verify where is clogged, where the flow of salt water decrease, or where the temperature of the salt water increase a little. This is the salt water side. What about the coolant side? In the coolant side, start on the reservoir, continue into the expansion tank where the cap is located, similar to the radiator cap, that cap. After that, the heat exchanger. After that, enter in the circulating pump or coolant pump. After that, the thermostat located in the thermostat housing. After that, the coolant circulate through the engine and return again and continue the cycle. You need to analyze both cases and verify where is the problem of temperature. For that reason, the temperature gun is very important. You need to keep in your pocket the temperature gun to analyze what is the cylinder with high temperature, what part of the engine, the elbow of the exhaust is critical, and analyze where is the problem. If you fix the problem, after that, you can clean the codes and verify, turn off the engine for more than 1 minute, disconnect the positive of the battery for 1 minute, put it back the positive and verify if the code stay again. That's the procedure. It's simple. Alright? We are going to check right now, those are the codes. We are going to check the signal, normally on the coolant temperature sensor. The signal, the computer supply 5 volts. That's the signal entering into the sensor, 5 volts, to the coolant temperature sensor. 2 volts when the engine is too cold, and 0.5 volts when the engine is warm. How can I verify those voltages? Oh yeah, with the tool that I explained at the beginning with Mr. Rodriguez. You disconnect, you connect the tool in series, and with the engine running at operational temperature, you verify those voltages. Complicated? No, it's simple. That's the procedure. Oh, in the manual of my book, it's not 0.5, it's 0.4. Okay. This is a generic explanation for any type of engines. Probably, in particular, in your engine is 0.4 and the maximum is 1.8. Yeah, the only that I want that you understand is that the procedure is similar. Alright, those are the signals. Let me check what happened with what is the cause? For what reason? Probably, once again, in this moment we are talking about coolant temperature sensor problems. Probably you have background. Background, my friends, is always in all the possibilities for the different type of sensors. Background is the most common problems related with engines. Doesn't matter if the engine is marine or agricultural or any type of engines. Background is a very common source of problems. Inappropriate coolant, don't forget, use the coolant recommended by the manufacturer. That's mandatory, that's important. Run thermostat, that's possible. Clogged heat exchanger or radiator. Issues with the coolant pump or circulating pump or freshwater pump. Or problem with the raw water pump also. It's very common. Bad oxygen sensor. Bad oxygen sensor. Bad expansion cap. probably the radiator cap or expansion tank is bad. How you know if that cap is damaged? When the engine is running at operational temperature, you see a little amount of vapor, steam coming out through the cap. In other words, the cap don't close properly, don't seal appropriated. Leaks of the coolant. My friends, I explained in the chapter dedicated to cooling system. If you have a leak, your problems start. If you have a leak, you have intrusion of air. If you have intrusion of air, you have vapor. If you have vapor, you have problems. Other very common possibility for coolant temperature sensor code activated is the mixture is lean. The mixture is lean, not rich, lean. I have more oxygen and less fuel. The mixture is lean. I recommend with the temperature laser gun, check in what cylinder is the problem and isolate the problem. Probably in that cylinder the injector is opening improperly or the injector is damaged. And the other one is the wastegate. In diesel engines the actuator is working improperly. Or the map sensor is sending a wrong signal, or the hose from the map sensor is broken. Those are the most common possibilities. My friends, right now you can analyze those situations.